if you were going to turn in your assigned problem to get points back on the test 2, that's due today by the end of the day. You'll find your problem on Canvas if you select comments after selecting the test. We're getting ready for our third test on Thursday. And then Friday, problem set 3 is due. So we're going to start our last chapter today. Pretty excited? Yes.
And this will be on the test?
Today's material won't be on Thursday's test. It will be covered on the final exam.
Okay.
But the section we're covering today is pretty well related to the stuff we're doing. It's not going to seem like, we're going to do a lot of factoring and stuff, so it kind of relates back to what we were doing in Chapter 6 anyway. Okay. Should we... and then today's Tuesday. So tomorrow's recitation, we'll work on the problem set. Thursday, I have an 8 a.m. recitation for my other section. You're welcome to come to that if you're still working on the problem set and have questions that you'd like answered. So I encourage you to take advantage of that time. Also, please, if you haven't done so already, use this link posted at the bottom of that top module to indicate which day you're going to take the final exam. You have 2 options. One is the Wednesday of exam week at 1 o'clock, and the other is the Saturday at 10 o'clock, which some people have actually chosen. So, because it depends on if you want a little extra time or a little more time to prepare. Okay, should we get started? So we're looking at quadratic equations. And a quadratic equation is one that can be written in this form. A lot of equations may not look like this initially, but what makes it quadratic is that we have an x squared term. We may or may not have the x term. We may or may not have like a non-zero constant term. Usually we do have some combination of those, but in order to be quadratic, you have to have that x squared term. If a were equal to 0, then it would just be linear, right? And we already know how to do those. So we call this the general form of the equation. Here are a couple quadratic equations. Here it is already written in that general form. Over here, that's still quadratic because squared is the highest power of t. It's just not written in that general form yet. But we could just collect all the terms on one side to get that equation. Or this one, right? If you take the equation on the left here, and just zap everything with a -1, you get that equation. It still fits that form if it's set equal to 0. And we'll have the same solutions. And there are 3 techniques that we'll use to solve quadratic equations. I'll say 2.1 techniques. 2.01 techniques, if we're counting them. There are 2 real algebraic techniques for solving. Factoring, which we're going to cover today, and then completing the square, which is nothing short of just magic and awesome and wonderful thing to do all the time. Okay? And I love factoring too, but completing the square is just this next level, super rad trick. The quadratic formula you might have had some experience with. I want to be really clear. I will never, ever, not once, ask you on a quiz or a test or the final exam, right? Which is the only thing that you're going to see this on. Solve this by using the quadratic formula. I don't care if you know the quadratic formula. It can be useful sometimes, but that's why I say we have 2.01 techniques. These are actual techniques where we understand how to solve it. This is just knowing a formula and plugging some numbers in, and that can be useful, but it is not anything I put any weight on. We'll in fact derive the quadratic formula. The quadratic formula is what you get when you complete the square on a generic quadratic equation. So, but today we're going to focus on factoring. Are you excited? Okay. Now, the backbone of this technique is Theorem 7, which says, suppose you have a couple of numbers. If you multiply those numbers, if you multiply 2 things and get 0, the only way that can happen is if one of those things was 0 in the first place. In fact, that general fact is stated when we multiply two things together. It's actually true no matter how many things. If I multiply three things together and get 0, one of those three factors has to be 0. So you can kind of extend this to however many factors you might have. For a proper quadratic equation, we're only ever going to see it as multiplying two things to get 0. So what's really important here, I'm going to really emphasize this. This is only true when it's equal to 0. If it's equal to any other constant over there, there's nothing that we can conclude. Like if I multiply two things and get 1, if they're two real numbers, there's actually infinitely many real numbers I can multiply by to get 1. Certainly 1 and 1 and -1 are two whole number solutions, but 2 and a half, 3 and a third, √2 and 1 over √2, there's uncountably many solutions. So it's only when it's set equal to 0 that we can invoke theorem 7. So if our equation is equal to 0, like we see in 7.2, all we need to do is look at that left side and say, can we factor that? What can we do there?
Take a t out.
Take a t out. And then what are we left with inside?
3t minus 2.
3t minus 2. So now, this is a product. I'm multiplying two things and getting 0. When we invoke theorem 7, that tells us that either t is equal to 0 or 3t minus 2 is equal to 0. The only way that that equation is equal to 0 is if one of these equations is 0. One of these equations gets us one of the solutions, t equals 0. And the other one is just a linear equation that we can solve, right? If we add 2 to both sides, then 3t is equal to 2. And then we can divide by 3. And we get t is equal to 2/3. Two solutions. Quadratic equations, when we look for real number solutions to quadratic equations, we'll find that there is either going to be two solutions. A lot of the time there'll be two solutions. Sometimes there'll be one solution. Sometimes there might not be any solution. Let's do another one. This one's already set equal to 0. So if it's already set equal to 0, what do we do? Yeah, see if we can't factor. So does this factor? How does it factor?
6 and 1.
So 6 and 1 like that?
Yeah.
What
Left
else?
side is negative, the right side is positive.
Well, they're going to multiply out to be a positive 6. So they're either both plus or they're both minus.
Never mind. 6 and 1 is 1.
2 and 3? And that's it?
Well, x plus.
X plus 2, x plus 3. Yeah, that'll work because then we get plus 2x and plus 3x, and that gives us the plus 5x. Great. Okay, so now we have a product set equal to 0. What next?
Set nothing to 0.
Yeah, we're going to set each to 0. That means that either x plus 2 is 0 or x plus 3 is 0. And these are pretty simple to solve, right? So we get x equals -2 or x equals -3. Sometimes people get caught up on the semantics. So if this product is 0, that means x plus 2 is 0 or x plus 3 is 0 means x is equal to -2 or x is equal to -3. Like the only way this is 0 is if x takes on one of those values. But then also we would say that x equals -2 and x equals -3 are both solutions. I mean, that's just sort of like details of the language we use. But you'll hear me use the word or a lot just because it's kind of partitioning the set of possibilities for the single variable that we have. Are we having fun? You don't look convinced, Jacob. You, him. I would say Jacob B, but you're both Jacob B, so Jacob Vance looks very impressed.
I'm very
Thank you.
impressed.
Yeah, good. What do we notice about this one?
It's not set to 0.
It's not set to 0, so what do we do?
Subtract 2.
Yeah, let's collect all terms on one side. We'll subtract 2 from each side. Until it's set equal to 0, it makes 0 sense to try to factor anything, right? we can only draw conclusions from factoring if the quadratic is set equal to 0. So now our equation looks like this. Now it's worth seeing, does this factor? What do we think?
No. And actually, wait, no, there's a 2, so yeah.
Yeah, you can do.
So 2x and x.
2x and x.
And then 1.
Is it minus?
Yeah, they're both minus.
Yeah.
Because the last term is positive. So
Mhm.
And then 1 in the first one and 3 in the next.
All right, so let's see. Quick check. This gives us negative x, negative 6x, and that gives us negative 7x. Good. And from here, we get to invoke theorem 7, which says that the only way that product is equal to 0 is if 2x minus 1 is equal to 0 or x minus 3 is equal to 0. The second one, x minus 3 equals 0, we get an answer pretty much straight away. X is equal to 3. And then here we're just going to solve that quadratic, or that linear. So we get 2x is equal to 1, and then we can divide by 2. And we get x equals 1/2. Fun? Okay. What about this one? Is it a quadratic?
Not
Hmm?
yet.
Not yet. Well, it's not written in that general form. A quadratic is a quadratic, like, even if it's in disguise. You know, like, so it's not written in that general form, right? It's not ax squared plus bx plus c equals 0. But keep in mind that the definition is that a quadratic equation is one that can be written in that form, even if it isn't already. So you're saying, when you say not yet, you're thinking maybe we can write it in that form.
Yeah.
What would we do to get that done?
You can subtract the 5x.
You could what?
Subtract the 5x or subtract the raised term. One of the randoms.
To get it set equal to 0?
Yeah.
Okay, so like if we subtracted 5x squared, that you mean?
Yeah.
Like that? So if we did that, then it would look like 0 equals 7 plus x times 11 minus x minus 5x squared. Is that how we need it to look? What's wrong?
It's not order.
It's what?
Well, you gotta distribute the x. Right?
We gotta distribute the x, right? So we want everything multiplied out in that general form. Right, we just have everything multiplied out, and we've collected our x squared terms and our x terms and our constant. So let's distribute that x. So we have plus 11x minus x squared. We have like terms here at the end that we can combine. 7 plus 11x minus 6x squared. Now, I don't know about you, and you might be better at this than I am, but whenever I'm thinking about factoring a trinomial, I get really mixed up if my x squared term isn't positive. I don't know, something about just the way, like the habit that I'm in. And it's set equal to 0, so I'm going to do a couple of things. I can make that a positive 6x squared easy, just zap both sides of the negative 1. And at the same time when I do that, again, it's something with like just the way I see it. I really like, it helps me to factor when I start with the x squared term. So I'm going to multiply both sides by negative 1, and I'm going to just rearrange the order of the terms on the right side. We get 0 equals 6x squared minus 11x minus 7. So now we have this quadratic that's set equal to 0. And let's see if we can't factor this.
X minus 7 and 2x plus 1.
3x minus 7 2x plus 1, so let's see what we get. I'm just doing a quick check. So we have a minus 14x plus 3x, and that does give us negative 11x. So this should work. And so now that we have it factored and set equal to 0, what comes next? Theorem 7, right? Like, and what does Theorem 7 say?
Set both to 0.
Yeah. So Theorem 7 says that if that product is 0, then either 3x minus 7 is 0 or 2x plus 1 is 0. Those are both linear equations. We know precisely how to solve linear equations. So we'll add 7 to both sides on one of these. We'll subtract 1 from both sides of the other equation. So we have 3x is 7, or 2x is negative 1. And now it's all over but the shouting. X is 7/3. X is negative a half. I want to do 3 more examples with you. That's not in the packet that you have, so I've got an extra handout here.
Yeah. Moet je iets aan de kant checken?
Okay. So, in the first example, that's a quadratic, already set equal to 0, ready for us to factor, right? So how does this factor? X minus 3, x minus 3. So now when we invoke Theorem 7, we find that means that either x minus 3 is 0 or x minus 3 is 0. What's our solution? X equals 3 or x equals 3, right? So we get one solution. This is the way in which we get a single solution in these. Like that if you could factor it and you get 2 of the same factor, there's an example of a quadratic that will have just one solution. In this next one, like, what do you notice here?
X cubed.
It's x cubed. It's not a quadratic, right? Now the quadratic, x squared is supposed to be the highest power. Yeah, so not only is it x cubed, it's not quadratic, but we're not sweating it because every term has a factor of x. So as Austin suggested, let's take out a factor of x. And then what's left in the parentheses, 2x squared plus 7x minus 15 equals 0. That's a quadratic in the parentheses, and we could try to factor that, right? I mean, we've been factoring for a while, right? All through chapter 6, doing a lot of factoring. So, so when we factor, we always mean factor all the way. And how does that factor? I guess we need a 2x and an x. That's the easy part. Now you guys finish the hard part.
2x minus 3x plus 5.
2x minus 3x plus 5. So this is minus 3x plus 10x, and that gives us the plus 7x. So good. Now, look at this. It's not a quadratic, but we can still invoke Theorem 7. Theorem 7 is stated if you multiply 2 things together to get 0, then one of those has to be 0. But that result is true no matter how many factors. Here I've got 3 factors. This times this times this is equal to 0. Still, it's only going to, the only way that's 0 is if one of the 3 factors is 0. So that gives us a couple possibilities. That means that either x equals 0 or 2x minus 3 is equal to 0. Or x plus 5 is equal to 0. X equals 0 is just one of the solutions now. And then we have these other pretty simple linear equations to solve. So 2x is equal to 3, which means x is 3 halves. And over here, if x plus 5 is 0, then subtracting 5 from both sides gives us x equals negative 5. So here we had a cubic, right? Degree 3 polynomial set equal to 0, and there are 3 solutions. How's that? Pretty fun. Let's do one more. This one's not quadratic, but this is a really good one to do, sort of thinking about, you know, preparing for Thursday. There's a lot of solving equations like this, right, in chapter 6. How do we start a problem like this?
Hang on with it, I would say.
No. The denominator.
What about the denominator?
Least common
Uh-huh.
denominator.
Yeah. So what is the, so certain, first of all, you can get everything on one side, but eventually you'll still have to use this. What is the LCD in this case?
X plus 2. Right?
Say that again?
X and
Yeah. X times x plus 2. Remember, x and x plus 2 are just completely different. Like 3 and 5 are different factors. They're relatively prime. X and x plus 2 are both, like, I guess we consider them prime algebraic factors. They don't share any common factors with each other, so we need to grab them both. And then what is it that we do with that?
multiply each by what?
Yeah, so I'm going to just leave myself a little bit of space. And then multiply. So we got some canceling we can do here. The x's cancel. Here the x plus 2's cancel. So we start on the left side. We have 2x x plus 2 minus x plus 2. Notice I'm keeping the x plus 2 in parentheses because I have to subtract that whole thing. And on the other side, what are we left with? 3x. So we've gotten rid of fractions. Now what do we do?
Distribute the 2.
Yeah, let's distribute the 2x, and as I'm doing that, so I'm going to distribute this here, and then I'm also going to distribute that negative just to get rid of parentheses. So we have 2x squared plus 2x minus 2 equals 3x. Now this looks like a quadratic. So the original equation that we looked at is not a quadratic equation, but solving it requires us to solve this quadratic. Austin, did you have a question?
Wouldn't that be 4x?
Oh, yeah, thank you. Other questions? So quadratic, the highest power of x is x squared. Let's have it equal 0. Let's subtract 3x from both sides. And as we combine like terms, I think all the x's cancel. Right, 4x minus 3x minus x. So we end up with just 2x squared minus 2 is equal to 0. And solving by factoring, would have us factor that left side. So I guess we could take out a 2. And then x squared minus 1 will factor. How does that factor?
X plus square x minus 1.
Yeah, it's a difference of squares. Now, look, we have a product of 3 factors set equal to 0, which we saw in the last example. And we said, well, that means that we might get 3 solutions, right? This is a product is only 0 when one of its factors are 0. But I'm going to go out on a limb here. I'm going to state very confidently that 2 is never equal to 0. So I don't have to consider that, right? This is still going to have just 2 solutions. So invoking theorem 7 gives us these equations. And we have x equals -1 or x equals 1. How's that? Pretty great. questions on any of these examples? So, so that's it for new material today. We're going to finish this chapter Tuesday, right? So Thursday class is for test. Tuesday's class is for finishing this chapter. There's 2 sections left, and we'll be able to get that done in one class easy. And then the recitations next week and class time on Thursday, next Thursday, we'll be working on a practice final exam that I'll have ready. On the problem set isn't due until Friday, right? Like you got that extra day. So recitation tomorrow, you work on the problem set. Recitation, come to recitation Friday. If you haven't finished the problem set and turned it in by Friday's recitation time, I'm going to expect to hear from you and maybe even see you here in recitation. Like I want to make sure everybody gets their work in. If you haven't already turned in your assigned problem to get points back on test number 2 and you want to do that, now this is a good time to work on it, or you could work on the problem set, and I'll be around to answer questions.